Okay, welcome back. In this video, we are going to look specifically at what's called the double angle identities. So double angle essentially means instead of looking at, say, the sine of x, now we're looking at the sine of 2x. So here we have, again, a bunch of identities. And so notice the first one, I have the sine of 2x, so that's your double angle, so you get 2 sine of x cosine x. The cosine of 2x, you get choices, okay? And so with these choices, when you are verifying problems, one of the things you're always going to have to do is you're going to have to try and decide which cosine identity you want to use, and that's going to depend on the problem that you're working with. Now notice your tangent also has two possibilities. You have 2 tangent x over 1 minus tangent squared, or you've got the sine of 2x cosine of 2x. Okay, so depending on, again, what you're doing is going to depend on which you choose to use. Now we also have the cosine squared of a double angle and the sine squared of a double angle, but notice both of these are almost identical. The cosine squared of your double angle is 1 plus the cosine of 4x, whereas the sine squared is going to be 1 minus the cosine of 4x. And no, this is not the cosine to the power of 4, this is the cosine of 4x. Okay, kind of like your double angle, instead it's a quadruple. So when you're working these problems, in order to solve them, you have to not only use the identity, the appropriate identity, but you have to draw your reference triangle and make sure that you are putting it in its proper quadrant in order to find your values for x and y, or as needed. If you put your reference triangle in the wrong quadrant, you do run the risk of throwing the entire problem off, so you need to be very careful. So if you are very shaky with your reference triangles, do make sure that you practice those big time, because double angles will refer heavily on your ability to use them. Now, the easiest thing to do is that the first thing you want to do is determine, you always want to determine your quadrant, where things lie. So you want to determine the quadrant that your double angle lies in, which means you want to look at your signs for your sine or cosine of your double angle. Now, here's a little thing to remember, or at least a helpful hint, is that x is your cosine, y is essentially your sine. So sometimes those help, but those are just some hints for you. So the best thing to try and get a handle on double angles is just to see some examples, and so I've got some of those for you. So here in this first one, you need to find the exact value for the sine of 2 theta, cosine 2 theta, tangent 2 theta. And you need to determine where the quadrant of 2 theta actually lies in. So we give you a little bit of information to use. So first we tell you the tangent of your angle is going to be -5/12. We also tell you that your single angle lies in quadrant 2. So what we have done here, this piece that we are giving you, is going to allow you to set up your reference angle. Okay, that is what we're giving you, is the information for you to set things up. So we're telling you your angle is in quadrant 2. So what that means is that we're going to go ahead and draw our quadrant here. And this is quadrant 2. So my angle is going to be somewhere here, I don't know where. So I'm going to go ahead and drop in, and I'm making it a dotted line because we don't know what the angle is, but this piece right here is going to be your reference angle. So here with this, we're telling you the tangent of that angle is going to be -5/12. So tangent is opposite over adjacent. So here my opposite is positive, so this is 5, which means my adjacent is the -12. And again, this is actually a special triangle. It is the 5, 12, 13, but please use Pythagorean's theorem in order to solve for your missing side. Okay? So just as a reminder, Pythagorean's theorem says a squared plus b squared equals c squared. And in that, c squared is going to always be your hypotenuse. Okay? It means in general a squared is going to be, say, opposite, which makes your b squared adjacent. Okay, so that's just a helpful hint here. So back to doing our double angles. So we have the sine of 2 theta. So the first thing we need to do is we need to remember what that's supposed to look like. So the identity itself says that you are going to have 2 sine of theta cosine of theta. So in order to solve for the double angle, it says that I have to plug in. So this is going to be 2. Now the sine of theta, so I'm talking about this reference angle here. Sine is opposite over hypotenuse. So this is going to be times 5/13 times the cosine. Cosine is adjacent over hypotenuse. So this is -12/13. Now here you would go ahead and use your calculator. You would multiply all of this together, and you would end up with -120/169. And so that would be your double angle here. So here we go. This is the sine of 2 theta, and this is what we were looking for. So 1 down, 2 to go. The next thing I have is I have the cosine of 2 theta. And again, you have 3 choices to choose from. You can choose whichever of the 3 at this point in order to solve. And so here, why don't we go ahead and use the one most choose. So this would be the cosine squared of theta, and then we would have minus the sine squared of theta. He is the version chosen most often. And so in this case, what we're actually going to do is we are going to take the cosine of theta. So again, this is going to be adjacent over hypotenuse, so -12/13, and we are going to square him. And then subtract the sine. So in this case, this is going to be 5/13, and again, we're going to square it. So when we do that, we end up with 144/169 minus 25/169 means your cosine of 2 theta is going to be 119/169. And this was what we were looking for. Alright, now the last one that we have to do is the tangent of 2 theta. And so in this case, we can do a couple of things. Well, one of the ways we can do tangent is we have the sine of 2 theta over the cosine of 2 theta. Now the reason this version is easy is I already found the sine and the cosine. And so here, I could just simply plug it in. I know the sine was -120/169, And I'm going to divide this by the cosine, 119 over 169. My denominators are the same, so I know that the tangent of 2 theta is going to be negative 120 over 119, and here is my third double angle. Now, the last thing I have to do is figure out the quadrant this lies in. So take a look at the signs. I have my sine is negative, my cosine is positive, my tangent is negative. This is where you have to remember this really cool saying that says when you look at your quadrants, so we have that this is 1, 2, 3, 4. We have a saying that says all students take calculus. Now what this tells you is the sine functions that are positive in that quadrant. So here all stands for all of them. So this is going to be all. S, this is my sine functions. So sine or cosecant. T stands for tangent. So this is going to be the tangent or the cotangent. C stands for cosine. So cosine or secant. So when you look at these, we are looking for which double angle is positive. And in this case, my cosine one is. And because that's the only one that's positive, it means that my double angle lies in quadrant 4. So the last part of your answer is that the double angle lies in quadrant 4. Alright, let's take a look at another one, slightly more complicated than the previous. So here we're told that the cosine of x is negative 2 over the square root of 6, and that the sine of x is positive. So again, that goes back to what we just talked about. Okay, so I'm telling you the sine of x is positive. So again, if you remember, all students take calculus. My sine is positive in quadrant 2. So my reference angle here, again, is going to fall here into quadrant 2. So I'm going to draw my little angle. So here, again, is going to be my reference. And now I have that the cosine is negative 2 over the square root of 6. So cosine is adjacent over hypotenuse. My adjacent is negative, so this is negative 2, which means my hypotenuse is the square root of 6. Now in looking at this, it's not necessarily easy to see what the other term is going to be. So here I would do that my b squared is equal to c squared minus a squared. So here I have the square root of 6 squared minus negative 2 squared. So in this case, this is going to give you 2, but I want b. So here, this is the square root of 2. Okay, so again, to make it clear, b then equals the square root of 2. So I have my triangle, which is what I want, and I need that to reference. So again, just like before, I gotta find the 3 double angles. So let's go ahead and start with the easy one, sine. Sine of 2 theta is again going to be 2 sine of theta cosine of theta. So here I'm going to go ahead and plug in. This is 2. The sine of theta is going to be opposite over hypotenuse. So this is going to be the square root of 2 over the square root of 6 times the cosine, negative 2 over the square root of 6. So we have to kind of do a little bit of fun math here. So I would multiply straight across the top. I have 2 times negative 2, which in this case is going to be negative 4, and then I've got square root of 2. And then square root of 6 times square root of 6 is just going to give me 6 in the bottom. However, you need to reduce. So here, my sine of 2 theta is going to be negative 2 square roots of 2 all over 3. And here is my first double angle. Alright, let's look at the next. So here we're going to do the cosine of 2 theta. Again, using the one used most often. Here we would have cosine squared of theta minus sine squared of theta. So here, plug things in. Again, your cosine is going to be negative 2 over the square root of 6. This time we're going to square it. And then minus your sine. Square root of 2 over the square root of 6 and square it. So in this case, when we square your top, you're going to have negative 4 over 6. We're going to subtract out 4 over 6. So here we're going to go ahead and sorry, this is a 2 over 6. So here we're going to combine. So I have that's my problem. So this becomes 2 over 6, which is going to reduce down, so the cosine of my 2 theta is equal to 1/3. Alright, so there I just demonstrated that obviously I'm human and we all tend to make mistakes. So, as a learning opportunity, one of the things that you could notice is that it is always a good idea to keep looking back over your work. So as I was working through it, one of the things that I kept doing is referring back to the top, which is how I noticed the 2 blatant errors that I had made here. Okay, so when things are starting to feel a little funny in math, usually it's because something's gone a little bit wrong. Alright, so let's look at the tangent of 2 theta. And again, I can make things really easy on myself, knowing that I can take the sine of 2 theta over the cosine of 2 theta. Since I already did all the hard work, I know this is going to be negative 2 square roots of 2 all over 3, and that whole thing is over 1/3. My denominators are the same, so what that means is that my tangent of 2 theta is going to be negative 2 square roots of 2. And so here's my third double angle. Now, just like before, we have to look at your sines. So my tangent is negative, but my cosine is positive and my sine is negative. So because of that, we know that 2 theta lies in quadrant 4. And that's purely because, again, your cosine is the only one that was positive. So there is 2 examples, one a little bit more tricky than the other, of being able to find the double angles using the double angle identities. So if you have any questions, or if this second example just totally confused you and you want to walk through it again, I would be more than happy to do that. Just go ahead and let me know. Otherwise, I hope you had as much fun as I did, and I look forward to seeing you next time.